Welcome to Mr. Tompkins EdTech and my series of exam question compilation videos on key topics you might still be struggling with.
This particular video covers growth and decay.
I've taken related questions from my past paper walkthroughs and given them to you here back to back. These compilation videos will give you a deep dive on topics you are still finding challenging, giving you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 3. In January 2018, an art collector bought an antique painting. In January 2020, he sold it for £17,640. Assume that the value of the painting increased by 5% each year. Calculate the art collector's profit. You must show your working. Okay, so this appears to be a reverse compound interest question, doesn't it? Because we're applying 5% over a number of years. How many years is it? 2018, 19, 20, so 2 years. So normally when you do a compound interest question, you take your value and you multiply it by your multiplier, and then you raise that multiplier to the number of years that you've got, isn't it? Okay, so in this case, I don't know what the amount is. I'm just going to call it A for now. I'm going to multiply it by a multiplier of, well, if it's 5% a year, 5% increase is 1.05 as a multiplier, isn't it? So that's times 1.05 raised to the power of the number of years, which is 2. And I know that is equal to 17,640 because it tells me in the question. Okay? Yeah, so that came from the percentage increase. And A is what we're trying to find, isn't it? We want to try and find the... we want to find the profit. So I need to find A, and if I take it away from the amount, then I should get the profit, shouldn't I? Okay, so I need to work this backwards to find A. And I can do that just by rearranging. Divide both sides by 1.05 squared. Okay, and then it will disappear on this side and then just reappear on the other. So A is going to be 17,640 divided by 1.05 all squared. Okay, so typing that into the calculator, 17,640 divided by 1.05 squared comes out to 16,000. So then his profit then is going to be the difference between those two amounts, isn't it? What he paid for it, what he sold it for minus what he paid for it. Okay, so 17,640 minus 16,000. That's a difference of 1,640. So that's going to be his profit then, isn't it? He's made 1,640 on the sale. Okay, nice work. Question 8. 1,600 fish are released into a new lake which has no fish. The number of fish is expected to increase by 5% each year. The table shows the expected number of fish in the lake at the end of the first year and then the end of the second year. Complete the table, round your answer to the nearest integer. Okay, so this is a little bit like compound interest where the population starts off at 1,600 and increases by 5% each year. Okay, so if I was doing this as like a compound interest question, final, original, multiply, put your thumb on it. I use this triangle here for percentages questions. Then the final is the thing we want to find. The original is our starting value, which is 1,600. Okay, comes from there, look. And then the multiplier is going to be, well, it comes from here, an increase of 5% each year. So when you're doing a percentage increase, you always start with 100%. If I add on 5%, that's going to give me 105%, which is 1.05 as a multiplier. Okay, so then to do the first year, I would do like final equals original times multiplier. which is 1,600 times 1.05. Now, if I do that one, it's going to give me the figure for the next year, isn't it? So if I do 1,600 and I times it by 1.05, I'm going to get 1680. If I times that by 1.05, I'm going to get 7640. So if I times the next one by 1.05, I'm going to get 1852.2, which I'm going to round off to 1852. And then if I times that by 1.05, I'm going to get 1944.81, which I'm going to round off to 1945. Okay. Part B says, use your table to draw a suitable graph to show the expected number of fishes in the lake. Okay, so 0 goes within that 1,600. That was the starting population. Goes here, look. And then the next one, in 1 year, it was 1,680. And now notice there are 5 divisions between 1,650 and 1,700. So each one of those divisions is going to have to be 10, isn't it? 50, 60, 70, 80, 90, and then the next one up. Okay, so 1680 is going to be 3 little squares up from 1650. It's going to be there. Okay, now the next one is at 1764. 1764. It's going to be between 176 and 177, isn't it? Kind of halfway, I guess. Okay, somewhere like that. And then the next one, 1852. It's going to be slightly above 185, isn't it? And then finally 1945. 1945. So it's going to be half a square below 1950. There. So I've plotted the points. Now you might be thinking that this is a straight line, but I don't think it is. It's actually, because you're multiplying through, it's actually like, it's going to actually be an exponential curve. So, I mean, it's looking pretty straight, but actually it is curving slightly. Just trying to make sure I skew all the points. Okay. Yeah, so if I compare that with a straight line, you can see, well, it isn't a straight line. It is curling slightly. Right, so a maximum of 2,000 fish can live in the lake. What effect would you expect this to have on the shape of your graph after 4 years? Okay, so I guess what's going to happen is, you know, it's growing exponentially, and exponential curves continue to get steeper and steeper and steeper and steeper and steeper and steeper like that, don't they? Okay, but that's not what's going to happen here, because you've got like an upper limit where of 5,000 fish that the pool can, or the lake can withstand, or, you know, support. So as the population goes up, all these fish are going to start competing for the resources in the lake, and that is going to add a downward pressure on the rate at which the population is growing. So what you're most likely going to see is, rather than a curve that looks like that, you're going to get a curve that kind of starts off the same way, but as it approaches that top layer, that top amount here, it's going to kind of flatten out like that. Okay, and then just slowly kind of approach the 5,000 mark. So that's what's going to happen here. So how can we put that in words? I suppose we can just say, I might leave my diagram on. I'm going to say then that the curve would flatten out as it approaches 5,000 fish. Oh, I misread that. It's 2,000, isn't it? Let me just change that. Should read 2,000. Don't know why I thought it was 5,000. Question 10. Paintings are sold in an art gallery. The cost of a painting has K% commission added to it. Tax of 15% is then added to the total cost to give the price to pay. Now, Layla correctly calculates the price to pay by multiplying the cost of the painting by 1.403. Work out the value of K. Okay, so the multiplier we've been using here then, the multiplier is 1.403. Now this multiplier of 1.403 has got to be equivalent to the two percentages that the gallery is adding onto the painting. So they take the cost of the painting and they're going to multiply it through by the multiplier for the percentage commission, and then they're going to multiply it again by the 15% increase, and that results in a overall multiplier of 1.403. Okay, so I'm going to say, because we don't know what this commission is first, let's call the first multiplier commission multiplier. Is going to be, I'm just going to call that M because I don't know it at the moment. And then you've got the tax multiplier. Now, if you've got 100% and you increase it by 15%, you've got 115%, which is 1.15 as a multiplier. Okay, so my multiplier of the M times the multiplier of 1.15, that has got to be the same thing as my multiplier of 1.403 then. Okay, so in other words, if I want to find my multiplier here, I'm going to divide both sides by 1.15 then, aren't I? So then M, my commission multiplier, is going to be 1.403 divided by 1.15, which is 1.403 divided by 1.15. That comes out to be 1.22. Okay, which is 122%, isn't it? Which means that the commission K must have been 22% then. So the 22% commission they added on would result in a 1.22 multiplier, and then the tax would be a further 1.15, and 1.22 multiplied by 1.15 is 1.403, so it seems to all work. Okay, commission is 22%. Question 10. In 2017, the value of a house increased by 4%, and in 2018, the value of the house then decreased by 3%. Teresa says, over the 2 years, the value of the house increased by exactly 1%, because 4 minus 3 is 1. Show that Tessa is wrong. Yeah, it doesn't work that way, in fact, because of the effects of compounding interest. You get interest on your interest in your second year, or decreases on your interest in this case. So it isn't going to work out quite like that. Let's just show what happens then. So in 2017, so this is my year. So how much do I start with? What's the change? And then what's the ending amount? Okay, so in 2017, I started. Well, we don't know what we started with. Let's just say we started with 100. Okay. So then, if I increased it by 4%, 4% of 100 would be 4, so it'd be plus 4. So I'd end up with 104, wouldn't I? Okay, and then in 2018, I would then have 104 to start with. Then what is 3% of 104? So 3% of 104 would be 104 times by 0.03. That would be £3.12. So that would be minus, we'd be taking off £3.12 from this amount. So 104 minus £3.12 it leaves me with £100.88. Okay, which is not £101. So if I went from 100 to £100.88, that would be an increase of 0.88% there, wouldn't it? So it wouldn't be 1%, it would be slightly less. So actual increase over 2 years is 0.88%. and not 1%. Okay, just not quite the same thing. Now, some students would struggle with this because there isn't a house of a price. You know, a lot of students would have found it a lot easier if they said the house is worth 100,000 or 150,000. So then they had a number to work with. We didn't have a number to work with here, which is why I made one up. I just made it a kind of 100, like to represent 100%, I suppose. Made the sum a lot easier just by giving it an arbitrary value to start with. Okay, so that is a good trick to use. If it doesn't give you a value, then just make one. You can then look at the relationship between your start and your end value to make a decision on what's happened, like we did here. Okay, but without that starting value, it would have been a more difficult question to answer. Question 14. A marathon takes place each year. In 2020, there are 6,500 runners. The prediction is, for each of the next 3 years, the number of runners will increase by 5%. Does this predict that in 2023 there will be more than 7,500 runners? You must show your working. Okay, so this is it's a bit like a compound interest question, isn't it? It's what we call growth. And it's a bit like a percentage problem. So for all percentage problems, I use FOM. Stick your FOM on it. So FOM. What's F? What's O? What's M? F stands for the final. That is what we're trying to predict. That's what we're trying to work out, how many runners there are in 2023. Original is the amount of runners that we start with, which is 6,500. Multiplier, now it's an increase of 5%. So if I've got 100% and I add on 5%, that gives me 105%, which as a multiplier is 1.05. So M is 1.05. Okay, so then covering up the thing I want to find the final. It tells me what to do with the other two things. Stick my thumb on the F, tells me that final equals original times multiplier. Okay, now we've got compound interest here, or growth. So there's one addition to this. We need to raise that to the number of years. And how many years is it? Years is 3, isn't it? So it's going to be 6,500 times 1.05, but that is raised to the power 3. Basically, you're multiplying by 1.053 times, aren't you? Okay, times 1.05 times 1.05 times 1.05. So type that into the calculator. 6,500 times 1.05 to the power of 3. That comes out to be 7,524. I'm going to write 25. I'm going to round it up to the nearest person. So I'm going to say that is equal to 7,520. Oh, I say we're going to round up 25. So does this predict that in 2023 there will be more than 7,500 runners? The answer, of course, is yes. This does predict 7,500 plus runners. Okay, so it's important that we answer the question in these. If you just write 7525, you're assuming the examiner knows what that means and you know what assumptions make. So let's not do that. Question 14. The population of butterflies in a park is 4,200. Part A says, assume that the population increases by 12% each day. Show that after 20 days the population would be greater than 40,000. Okay, so this is a growth and decay problem, which is pretty much the same thing as compound interest, isn't it? But with butterflies rather than pounds in the bank. Okay, so we're going to be doing it using our little triangle FOM, which I use for all percentage questions. Okay, and then we just need to work out what F, O, and M is here. Right, the final is the final population of the butterfly. So that is what we're going to be finding. The original is the starting population of the butterflies, which is up here, look. So O is going to be 4,200. 4,200. What's M? M, the population increases by 12% each day. So that's going to give us our multiplier. Now with percentage increases, we always start with 100%. I'm going to add on 12%. That gives us 112%, which as a decimal is 1.12. Okay? So what do we do now then? We want to find the final. So cover up the thing you want to find on the triangle, put your thumb on it, and that tells us what to do with the other two. Final equals original times by multiplier. So final equals original times by multiplier. Okay, which is 4,200 times by 1.12. But then that's if we did it once, but we need to do it a number of days, don't we? So we need to keep applying this this multiplier. We need to apply it 20 times. Okay, so we're going to raise that to the power of 20 there. Okay, so that we raise it there. So 4,200 times 1.12 raised to the power of 20. 4200 times 1.12 to the power of 20. That comes to 40,514 butterflies. And one looks like a squidged one, 0.43099 of a butterfly. Let us not dwell upon part of butterfly. 40,514. Okay, so show that after 20 days the population would be greater than 40,000. Population is 40514, which is greater than 40,000. Job done. Question 14b. In fact, the population increases by 13% each day for 19 days and then decreases by 8% for 1 day. After the 20 days, is the actual population greater than 40,000? Tick the box. Yes, stroke, no. Show your working to support your answer. So rather than what we had before of 4,200 times 1.12 to the power of 20, instead what we've got is we've got an increase of 13%. That's going to change my multiplier from 0.12 to 0.13, isn't it? So that's going to change. And then I'm only going to apply it now 19 times rather than 20. Okay? But I am going to apply an additional multiplier where it decreases by 8% at the end. So a decrease of 8%, what's that? If you start with 100% and you subtract 8%, you are left with 92%, which is 0.92 as a multiplier. So I'm going to multiply at the end, my last year, I'm going to multiply by 0.92. Okay, so the population is 4,200, the starting population, times by 1.13 19 times and 0.92 1 times. What's that then? So 4200 times 1.13 to the power of 19 times 0.92. So that comes out to be 39,402.8. I'm going to round that up to 39,403 butterflies. Okay, because I can't deal with parts of butterflies. Okay, so what's the question? Is the actual population greater than 40,000? No. Population is less than 40,000. Okay, so the population is less than 40,000. Question 16. The formula P equals 6,800 times 1.045 to the power of n is used to predict a population P of an island n years after 2018. Write down the population in the island in 2018. Okay, So if it's the actual year 2018, then n years after that, n is going to, we're talking about n is equal to 0 here, aren't we? N is equal to 0, okay? Because it's n years after 2018 and it's 0 years after 2018 if it's actually 2018. Okay, so what we're talking about here then is population is equal to 6,800 times 1.045 to the power of 0. And you should know that anything to the power of 0 is just 1, and anything times 1 is just itself. So it's just 6,800. Okay, write down the percentage growth rate used in the formula. Well, it comes from here, isn't it? 1.045. 1.045 is the multiplier. So the multiplier is 1.045. So the percentage is 104.5%. So the percentage growth rate, subtracting 100%, is 4.5%. Because remember, everything starts at 100%. So if you're doing a multiplier of 4.5%, or you want to work out 4.5% increase, you have to add 4.5% onto 100%, and so on. So the growth rate is 4.5%. C part 1 says work out the population predicted by the formula for the year 2030. So remember, the formula was population is equal to 6,800 times 1.045 to the power of n, where n is the number of years after 2018. So what is n first off? 2030 minus 2018, what's that then? That is a difference of 12 years. So n is equal to 12 here, isn't it? 12 years after 2018 is 2030. So the population is going to be 6,800 times 1.045 to the power of 12. What's that then? 6800 times 1.045 to the power of 12. I make that 11,531.9. Well, 99. I'm going to round that up to 11532. So 11532. Give one reason why the answer to C part 1 may not be reliable. Well, this model assumes that everything stays the same for the whole 12 years, doesn't it? So, but you know, things happen, don't they? You know, wars, famines, and whatever. So things can change over time. The situation can change. So the model assumes that the growth rate stays the same the whole time, but there may be circumstances that cause it to change. I'm just going to write down a few, like e.g. war, famine, etc. Any reason could be a good thing as well. I don't know. People could be given more taxes to have babies. I don't know. Question 16. Lee bought a house at the start of 2016. Lee assumes that the value of the house, V, can be predicted using the formula V equals 185,000 times 1.035 to the power of n, where n is the number of years after the start of 2016. Part A says, explain how you know that the value of the house is predicted to increase each year. Okay, well, you know it's going to increase each year because you're multiplying through by a number greater than 1. Okay, and so the multiplier 1.035 is greater than 1, so it increases on multiplication. Okay, so if you multiply through by a number bigger than 1, it's going to increase, isn't it? And if it's between 0 and 1, it decreases. So write down the percentage increase per year that is used in the formula. The percentage increase then, they're using a multiplier of 1.035, which is the same thing as 103.5% as a percentage. So if it was 100% and you increase it to 103.5%, it's an increase of 3.5%. Okay? Because you always start with 100 on percentage increases. So if you've got 103.5, it's gone up by 3.5. Write down the value of the house at the start of 2016. Well, that's got to be this value here then, isn't it? It's going to have to cost, that's our starting price, which is 185,000 then. Okay? Part D, calculate the predicted value of the house at the start of 2020. Give your answer to 4 significant figures. So 2020 is 4 years after 2016, isn't it? So that is our value of n. N is 4. So then the value is going to be, so the value is equal to 185,000 times 1.035 times to raise to the power of 4 then for 4 years. So that is, what's that, 185,000 times 1.035 to the power of 4. That comes out to 212291.7. Now it's asking our answer here to 4 significant figures, so I need to round that off. Let me just write down the display value first. 212291.7551. I probably wouldn't bother doing this if it was my test. So 4 significant figures then. 1, 2, 3, 4. We're going to round off after that 2 there. Next digit is a 9, which means I have to round up. So my 2122 becomes 2123. And I've got to pad it out with enough zeros to make it the same magnitude as it was to start with. So add another couple of zeros. So that is 212,300 to 4 significant figures. Right, compare with the value at the start of 2016 to show that the formula predicts the house will have doubled in value at some point during 2036. So in 2036, that is n is equal to what? That's 20 years, isn't it? So in 20 years time, what is the value? So value is going to be 185,000 times 1.035 to the power of 20. So what's that then? Let's just change that power of 4 to a power of 20. And that comes out to be 368,110. I'm going to just do the same thing. I'm going to round it off to 4 significant figures. So that is 368,1 then, I suppose. 00. Now to double, the value is going to have to reach 2 times 185,000. That comes out to be 337,000. Okay, so it's not quite reached that point yet, is it? Okay, so at the start, that's basically at the start of 2036. It's already 368,100, which is not quite double. So that's in 2036. Now in 2037, the value is going to be 185,000 times 1.035 to the 21, which comes out to be, so I'll just change that, 185,000 times 1.035 to the power of 21. That comes out to be 380,994. So again, rounding that off to 4 significant figures, that's going to be 381,000. So it's going to be 381,000. Okay, so So between those, so it goes past 370,000 between 2036 and 2037. Okay, so it goes between them, doesn't it? So it was 368 and now it's 381. So it must have gone through 370 at some point between those two dates. Okay, give one reason why this may not happen. Well, it assumes that you get this interest rate of 3.5% constantly for nigh on 20 years, which may not happen because who knows what's going to happen next year, let alone in 20 years' time. So I'm going to say that the interest rate, not really an interest rate, is it? It's the rate of increase may change due to economic factors during those 20 years. Okay, so the rate of increase may change due to economic factors during those 20 years. Sorry, my handwriting's so poor, I can barely read it myself. Question 21. The number of gannets on an island is assumed to follow the exponential growth model n equals 0.45 times 1.07 to the power of x. It's a little bit like compound interest, and it's interesting we've had a second question on the same topic here. N is the number of gannets in thousands, x is the number of years after the 1st of January 2010. Complete the table for n. Okay, now again, if you've got one of these nice Casio calculators, you can use the table function in here to work out what all the values are in these missing tables. It's quite handy. I'm going to quickly show you how to do it. So click menu, select the table option. Now the first thing that pops up is f of x. Now this is the function that you need to be putting in. Okay, so here I'm going to type in the bit after the equal sign. So it's going to be 0.45 times 1.07. Use the power button. And then up there I need to write the x. Now the x, you can see, is written in red above the right bracket. So to access it I need to press the alpha key, and that should pull up my x. Okay, so I've written in my function f of x, and it's what n is equal to in the paper. Right, when I press equals, if you've got the newer Casio model, you'll get an option for g of x. If you've got the older one, it will just skip over g of x. You can only put one function in. Not going to use the second function, so I'm just going to press equals again. Then it asks me start, end, and step. I'm going to be starting at 0 because that's my lowest value of x in my table. I'm going to be ending at 20 because that's the highest value of x in my table. And you notice the values in x are going up in 5s, so that's what the step is what you're going up in. So I'm going up in 5s. So if I press equals again, you should see it then generates a table for me. The first column has got my x values. You see it's got 0, 5, 10, 15. And if I scroll down, I'm going to get the next ones as well. And next to it in the f of x column, I've got the values of the function. Now you should be reassured to see that the first two match up. So I've got 0.45 for 0. I've got 0.63 and a bit more detail for 5. At 10, I've got 0.8852. So all these numbers are rounded to 2 decimal places. So I'm going to do the same thing. I'm going to round off that. I'm going to write in 0.89 under there for 10, 0.89. And then I got my 15 value. You should be reassured again that matches up with the one that's in the table. And then finally, I've got my 20 value, which is 1.74. I'm going to write that in, 1.74. Okay, job done. Thank you, calculator. Again, highly recommend you get a Casio calculator that looks like this one if you haven't got one already. And as mentioned before, there is a link below to my Amazon page where you can find this calculator and other recommended stuff for your exams. Okay, in part B I need to plot these points then. So let's just have a quick look at the scale. From 0 to 0.5, I've got 5 little squares. So each one of these divisions is 0.1, isn't it? So that'd be 0.1, 0.2, 0.3, and so on. Okay, it's important that you understand the scale before you start plotting points. Okay, so the first point I need to plot is 0 against 0.45. Okay, so 0.4 is here, 0.5 is here. The point I want is halfway between them, isn't it? Okay, so a little point there, halfway between 0.4 and 0.5. At 5, I need to plot 0.63. So 0.6 is here. 0.63 is going to be a third of the way between 0.6 and 0.7, isn't it? So a little cross there. 10 goes with 0.89. 10, 0.89, that's almost 0.9, isn't it? I'm just going to plot it at 0.9, I think. And then 15 goes with 1.24, which should be halfway between 1.2 and 1.3 then, shouldn't it? So it should be, lines are going, losing track of my lines. See there? Okay, and then finally 20 goes with 1.74, which is going to be halfway between 1.7 and 1.8, isn't it? Okay. Now you should see these form a kind of a curve. We need to join it up with a smooth curve. Okay, try and make sure you're using a single line. Mine's a bit wobbly, that doesn't really matter so much. What you will get marked down on is feathering, so like when you have like multiple lines like that can lose you mark, or missing the points entirely, so not actually going through the points will cause you to lose marks. Okay, but it should look something like that. Okay, and then finally it says use your graph to find the year when the gannet population is predicted to reach 1,000. Okay, so this scale n is in thousands, isn't it? So 1,000 is going to be here. Okay, so if I can then get my ruler out and read across from 1 or 1,000 until I hit my line. So read across from 1 until you hit the line. When you hit the line, I'm going to change direction and read downwards. Okay, so the answer I'm looking for is there then, isn't it? So it's a little bit more than 11. So what, 11? Should go for 11.5? I think I'm going to go for 11.5 there. So use the graph to find the year when the gannet population is predicted to reach 1,000. Okay, well I think 11, it's somewhere between 11 and 12, isn't it? But 11 it won't quite have reached 1,000, it'll be a little bit below. So I'm going to go for 12. So that's 12 years after the 1st of January 2010. So 2010 plus 12 is going to be 2022. So I'm going to say 2022 is my answer. Now, if you'd have rounded the other way to 2021, I think you would probably get the mark in this case as well. Just wanted to take a few seconds out to talk about my Patreon page, which you can find at patreon.com/Mr. Tompkins EdTech. On here you can gain access to exclusive content, including early access to my past paper walkthroughs. So if you like my content, definitely worth checking that out. Also, if you become a Pythagorean patron, you get a special shout out in every video. So check it out. Back to Question 22. At the start of 2018, the population of a town was 17,150. At the start of 2019, the population of the town was 16,807. It's assumed that the population of the town is given by the formula P equals AR to the power of T, where P is the population of the town T years after the start of 2018. Write down the value of A. Okay, so if P equals ART, then at the start of 2018, T is equal to 0, isn't it? Okay, so P is equal to AR to the power of T is going to be equal to AR to the power of 0. Anything to the power of 0 is 1, so P is equal to A at that point. Okay, so that means the population at the start of 2018 is the value of A then. So that's going to be 17,150. Okay. Okay, that was okay. So right, show that R equals 0.98. Okay, so now we know what A is. We can take the other value. We can say that at start 2019, T is equal to 1, isn't it? So then P is equal to AR to the power of T becomes, well, we know P at start of 2016, it's 2019, it's 16,807, and that is equal to A, which we now know, which is 17,150. R we're still trying to find, and T is 1, isn't it? So in other words, R to the power 1 is just R, so that disappears. So to find R, we're just going to divide both sides by 17,150 then, aren't we? So then R is going to be equal to 16,807 divided by 17,150, which is 49/50ths, or 0.98. Okay, so R is 0.98. Okay, show that the population is predicted to be less than 16,000 at the start of 2022. Okay, so now we've got the complete formula. Let's just write that down. So the population then now is going to be A, which is 17,150 times R, which is 0.98 raised to the power of T. So in 2022, then what's T then? So it's 0 in 2018, it's 1 in 2019, 2 in 2020, 3, 4. It's going to be 4, isn't it? T is equal to 4. So in 2022, T is equal to 4. So then P, the population, is going to be 17,150 times by 0.98 raised to the power of 4. What is that? 17150 times by 0.98 to the power of 4. Okay, so I'm going to round this off to the nearest person. I don't really want 0.6 of the person, it'd be too messy. So 15,819 then. 15,819 to the nearest person. So the population is declining, isn't it? Okay, it's got what we call decay for a exponential function like this. So it's decay in the population. 15,819. Right, now we've got a final part of the question. It says, use the formula to work out what the population might have been at the start of 2017. Can we do that? So, if 2018 T was 0 and 2019 T was 1, I assume in 2017, then T is going to be minus 1. Does it work? Let's find out. So then P is going to be equal to 17,150 multiplied by 0.98 to the power of minus 1. Okay, what's that then? I'm just going to come back and delete my 4. and put in a -1 instead. Okay. Oh, that comes out a neat number. 17,500. 17,500. Okay. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.